Welcome to Anatomy Physiology 1, Chapter 6, the Integumentary System. In this lecture, we're going to talk about your skin, your hair, your nails, the different things that make up the integumentary system. One of the things they should do when you go to the doctor is press down on the ends of your nails and look at your nail bed. When you push down and let up on it, you should see the pink go away when you push down, turns white, and then turn instantly pink. If you push down and then let up and it doesn't turn pink, then you're probably anemic. You don't have enough blood flow through the fingertips. So that's one of the things you can see just looking at the skin. Because the skin is the first thing that any pathogen encounters, we get more radiation to our skin. So if you get into a tanning bed or you go out and you lay out in the sun, most of the radiation will be absorbed by your skin. If someone hits you, you're in a car wreck, then your skin is one of the most vulnerable organs, as it says. If bacteria, fungus, viruses can get through the skin, then they can get into the body and mount an infection. And all the chemicals. One of the things that they didn't used to do was tell you what chemicals you were working with when you were in the laboratory or working in a factory, if there were any dangers to handling them. And if you haven't seen the movie Radium Girls, you really should watch it, because they didn't tell them that the radium that they were painting watch dials with was radioactive and would hurt them. And so what it did when it soaked in through their skin and got into their bones is horrific. So anyway, you should watch that. This is one of the reasons why we had unions. This is one of the reasons we got OSHA involved. So the skin receives more medical treatment than any other of organ systems. It's also your largest organ system because it covers your whole body. And the people who study skin, who study the hair and the nails, the integumentary system, are dermatologists. So it's the study of dermatology. We're going to learn the layers of the skin, and we're going to learn what's normal skin color and what's not normal skin color. This is an overview of the skin, and you should have gone over this in lab for sure. You should look at slides of the skin, and then you should look at a model that looks almost exactly like this one. This is a cartoon picture where they've shown you all of the different layers and all the different things that are inside the layers to help you identify where you are. But I'm going to be showing you some actual microscopic pictures in a minute. But let's go over this, and you have 3 layers. You have the dermis, which is this layer right here. You have the epidermis, which is laying on top of the dermis, so it's the epidermis. And then you have the hypodermis, which is below the dermis. So if you can remember, dermatology is the study of skin, and this is your dermis, and there's your epidermis and your hypodermis. Now the epidermis is dead. It has no blood vessels in it, but it is keratinized cells. It's squamous epithelium that we've talked about before. And where it meets with the dermis, you notice it's bumpy. This is called the papillary layer. And papilla is nipple-shaped. So these are nipple-shaped things. But what you and I call it, instead of your papillary layer, we call it your fingerprints. So you're having this pushing up of the epidermis. And everyone's fingerprints are different, including identical twins. So they'll not be leaving the same fingerprint. When you get down in the dermis, that's where most of the business is happening. You've got your blood vessels down here, you've got some muscles, you have nerve endings, you have your sweat gland, you have your hairs. So here is, let's see, let's look at this hair follicle. So here's your hair. Here's the root of the hair. This is actively dividing right here. So you've got to have blood vessels going to it to nourish it. But this part is dead. All the way up and out, that's just dead. So that's why it doesn't hurt when you cut your hair. Deep down, right above the hypodermis, you have nerve endings, and this is the Pacinian corpuscle. Right here, the Pacinian corpuscle, and it senses pressure. So if somebody's pushing against your skin, it's going to trigger this, and the message is going to go out and say something's pushing on your skin. The sweat gland and the sebaceous gland. This is the one that makes sweat, and it's going to come out at a pore. So all of these are sweat glands. And this is the oil gland, or the sebaceous gland, and it is connected to the shaft where the hair is coming out, right there. So it's going to lubricate the hair, keep it a little bit of oil on it. This sebaceous gland they've cut open so you can see inside of it, but here they've tried to show you what it looks like. So it's actually just a series of sacs that are making oil for you. Here's another sweat gland on the side. So the sweat gland is not connected to the hair, and the oil gland is. So in case you get confused about which is which, now you know. And then right at the papillary layer, at the very top of the dermis, you're going to have touch receptors. So this is a nerve ending that's going to tell you if something's brushing up against you. So this one is more pressure deep down, and this is touch, just somebody brushing lightly against you. You'll notice that the hypodermis is almost all fat. It's almost all adipose tissue. And you'll notice that you have blood vessels in this area, and you have mostly capillaries in this area. And one of my favorite muscles in the whole body are the Erector Peli muscles, and when it is contracted, it causes the hair to stand straight up. So you've seen animals do that where their fur stands straight up. But you have the ability to do that too. But because you don't have as many hairs, you can also see this little muscle when it contracts under the skin. And you and I call it a goosebump. So you get goosebumps if you're scared, and you get goosebumps if you're cold, because you're trying to pull your hair upright. On this slide, this is a picture that I took a long time ago with a microscope camera. Nowadays, I have the students use their iPhones, smartphones, and they can focus on something in the microscope and then take pictures using their phones. But back then, we had to have a special camera and have all these special attachments. Anyway, so I had a good time playing around with that camera and taking pictures. So this is a slice through someone's skin, and you can see the dead layer, the keratinized outer layer of the epidermis, and you do have some cells that are dividing right here and pushing up, and as they fill up with keratin, then they die. And right here is the papillary layer, and if you remember, the papilla, or the nipple-shaped things, are what give you your fingerprint. They also are the dividing point between the epidermis and the dermis. So down here is the dermis. You've got more connective tissue down here. And sometimes you get a virus that gets into the skin, and it'll cause you to grow a skin tag right there. So if you get a skin tag, you can either take a pair of scissors and cut it, but if you do, it'll bleed like crazy. So what they recommend you do is just tie a string around it, or they sell little teeny tiny rubber bands that you can put around it, and it cuts the blood flow off. And in a couple of days, it'll just die because it can't get any blood flow, and it'll just fall off. So the older you are, usually the more skin tags you have. You get them under your arms, especially on your neck, places where you chafe, where you rub against the skin. And then here's a joke. I think this is great. So here is, how do I get rid of oily face? My face is so oily, how do I get rid of it? And the best answer that the voters all chose was, getting rid of your face is not recommended, no matter how oily it is. The face serves many functions, and you should not try to remove it. This slide is a summary of all the things I just said, that the integumentary system is your skin, your hair, your nails, and any glands you have in there. It is your largest and heaviest organ. It makes up about 15% of the weight of your body. And then the layers are the epidermis, which is mostly stratified squamous epithelial cells. And then the dermis, which is a lot of connective tissue. Remember, you had capillaries, and that's where your hairs are. That's where your sweat glands start out. And then the hypodermis is just a fatty layer beneath the skin, but it defines your skin. So a lot of people think that it's not good to have fatty tissue in your hypodermis. But when that dissolves, when you get old, that's when your face gets all saggy and wrinkly. So we actually do want fat. You have thick skin and you have thin skin, and the thick skin has an extra layer. If you look at the palms of your hands and the soles of your feet, that's where you have the thicker skin. And it doesn't have hair follicles, so if you're looking for hairs on the palm of your hand, you're not going to see them, or on the soles of your feet. And you don't have oil glands either. That's why your feet get so dry and crack sometimes. The whole rest of the body has what we call thin skin. It does have hair follicles. It does have sebaceous glands, which is another name for oil glands. And it does have sweat glands. Now, there's an interesting story. One of the reasons that we try to make sure that all kids are vaccinated for measles is not so much for the kids, because it can cause problems with children. I know one girl who had the measles, and she ended up blind. So obviously you want to get your kid vaccinated for measles for that reason, but the other reason is, if a child gives an adult the measles while they're carrying a baby, a woman carrying a baby, whatever part of the baby is forming at that time will likely not form correctly. So I knew of a guy whose mother had the German measles when she was carrying him, when she was making his skin. And so he was born with none of the oil glands, none of the sweat glands, and none of the pigment in the skin. No hairs. So when you see the Pillsbury Doughboy, you know, with the very white skin, that's kind of what he looked like. And if you can't sweat, you're in danger of getting heat stroke. So it was really interesting to see someone who had no pores, no hairs, just perfectly smooth white skin. I always thought how neat it was that plants could do photosynthesis. They just stand there in the sun, soak up the sun's rays, and they can use the energy to make sugar and to make oxygen. And we can stand there in the sunshine and we get sunburn. So, but we can do a couple of things. One of them is we can do vitamin D synthesis. So we can take the cholesterol that's in our skin and we can process it and make it into vitamin D. And then the liver and kidneys finish out the synthesis. So people who don't get out in the sun very much oftentimes have vitamin D deficiencies. So in America, we put vitamin D in the milk. And if you look, it's in a lot of things like your bread. So you're going to find vitamin D added because we really need it. I showed you the Pacinian corpuscle, which is used for deep pressure. And then we have the touch receptors. But we also have receptors for temperature and for pain. So your skin is very sensitive. Another thing that you can do with your skin is, because you have those capillaries, and because underneath that you've got the blood vessels, if you're cold, you can constrict and put the temperature, put the heat, put the blood in the core of your body to try and keep the core of your body warm, keep your heart working, your lungs working, which is one of the reasons why we get frostbite. And then if you are really hot, then you're going to open those blood vessels up and you're going to run the blood up close to the skin, so hopefully some of the heat can dissipate away. So a lot of times when people get overheated, they turn beet red, and that's because their blood vessels right up under their skin are opening up, and so you can actually see the blood through their skin. And then they're perspiring. One of the things, if you know that a person is really, really hot, and you know that they've been overexerting themselves and all of a sudden they stop sweating, then that's a time to worry about heat stroke. So that's one of the things you look for. It's interesting that people who have acne or a scar or some physical defect of their face tend to feel that they're inferior, feel that there's something wrong with them. So your face is very important in social acceptance and in your self-image, how you perceive yourself. So that's a little bit surprising. And if you have the time, you should look up a series called Lie to Me, and it's all about micro expressions. It is absolutely a fascinating series. And I was devastated when they canceled it after just a few seasons. But micro expressions, there are certain things that your face does and the muscles underneath your face do that you don't really have any control over. So if you're trained to look at people's eyes and to look at their facial expression, you can tell a lot about what they're thinking. One of the stranger things that kids do when they're in elementary school or middle school is they learn that their skin, the epidermis, is dead cells, so they don't have blood vessels, and they don't have nerve endings for touch and for pain. And so one of the things we used to do would sit out on the playground with needle and thread, and we'd sew our fingers together. So as long as you don't put the needle down into the dermis where the nerve endings are, then you can sew your fingers together and you won't bleed because you don't have any blood vessels. And it freaks the heck out of your teacher and your other classmates. In just a second, we're going to talk about the 4 or 5 different layers of cells that you have. And the very bottom layer is called the basal layer or stratum basal. Down there you have cells that they're stem cells. They're not totipotent. They can only just give rise to other skin cells. But they can decide whether they're going to be keratinocytes or melanocytes. So they push up through. And the keratinocytes are making keratin, which is the protein that makes your skin waterproof. It also is what makes your fingernails and your hair. And then the melanocytes are the ones that make melanin. And melanin is the pigment that makes your skin brown. We need the melanin to shield us from DNA. So again, people who live close to the equator where there's a lot of sunshine, they're going to have darker skin. They're going to have more melanin to protect them. Otherwise, they can get skin cancer. So melanin is our very strong defense against ultraviolet radiation from it damaging our DNA to the point where we end up with skin cancer. So you only find these down in your basal layer, your stratum basal, but you have branched processes that stick out amongst the keratinocytes, and so the keratinocytes can take up some of the melanin that's made by the melanocytes. You follow that? All right. So here's your keratinocytes laying down the keratin layer, your dead epithelial layer, and then underneath it you have the melanocytes that are making melanin, but because they can stick out part of the cell membrane up through the keratinocytes can take in some of the melanin by endocytosis. So I don't think you're going to have any trouble remembering the outer layer of the skin. It's the stratum corneum, and that is the horny layer. And the reason it's called the horny layer is because you have the cells, you have the machinery to actually grow horns. So here's a woman who's grown horns on her leg and on her face. So the stratum corneum is the horny layer. And other animals grow horns. We don't usually see people doing this. But in the case of this woman, she has skin cancer. So if you look right here on her nose, there's kind of a little crusty place right there. So that's skin cancer growing right there. And then she has skin cancer growing right here, but because the cells are confused, they are growing this horn also. So you can grow horns without it being a cancer, but you always want to take a biopsy at the base of it and see if it is actually a squamous cell carcinoma, which is what she has. Now, I mentioned that you have the brown pigment to protect you from the UV rays, from the ultraviolet rays. So the darker your skin, the less likely you are to get skin cancer because you have the protection of the melanocytes and the melanin to take on the UV radiation before it gets deep enough into the body to mess up your DNA to where it causes a cancer. But a lot of people with dark skin feel that, well, because I have dark skin, I'll not get skin cancer. Just like a lot of men say, well, because I'm not a woman, I'm not going to get breast cancer. Men can get breast cancer, and people with dark skin can get skin cancer. They're just not as likely to do so. So one of my favorites, Bob Marley, passed away from skin cancer. He was only 36 years old when he died, but he was living in Miami, Florida. So if you know anything about Miami, there is a lot of sunshine, and it is a lot hotter down there than it is, say, up in Wisconsin or the more northern states. So just because you have dark skin doesn't mean you can't get skin cancer. So if you see any crusty places, go get them examined. Here's a typical skin cancer. So it tends to be red, it tends to be slightly raised, and in the middle it usually has a flaky, indented place. It's kind of a crusty place in the middle there. We've already mentioned the sensory cells, the nerve endings that are up inside the dermis. And one thing we did not talk about yet are the dendritic cells. So whenever you see the word dendritic, like the dendrites of the nerve endings, think of trees. So when we talk about the brain, you're going to have oligodendrocytes that we're going to talk about. So they project out like tree branches. So you have these white blood cells, macrophages, but they stick their cell membrane up through the skin. So if you're looking in the spiny layer or the granulosum layer, then you're going to be finding some of these projections from the macrophages. So anything that manages to get through the corneum, the outer horny layer, and get down into these layers, you've got the white blood cell waiting. And hopefully it will engulf it and destroy it before it can get any further in your skin. So here is an actual picture through a microscope, and then here's the cartoon version that kind of shows you what all is going on, what you should be seeing. So your horny layer, your stratum corneum, is this part right here, and it's the dead keratinized cells. And if you have if you're on the palms of the hands or the soles of the feet, you have the 5th extra layer, and that's the stratum lucidum, or the white layer, right there. And then the granulosum actually looks like it has little colored granules in it, right there. And the majority is the stratum spinosum, or the spiny layer, right here. And then, of course, your basal layer, or your stratum basal, is the very last one before you get down into the dermis. So the epidermis has 5 layers if it is thick epidermis, and it has 4 layers if it's thin. I put this picture in to show you someone who's having to have a skin graft, and they can lay some mesh down and then let the cells grow across the mesh. You need something to keep pathogens out because you've lost the epidermis. You don't have the outer layer of skin. You're trying to regrow it, so you've got to keep all kinds of infections out. You also have to hold fluids in. So that's another thing that your epidermis does for you, is it holds your moisture in, because the keratin is waterproof. So it keeps water on the outside from coming in, but keeps water on the inside from leaving. So if you burn a certain percentage of your skin off, that there's really nothing they can do for you. And this other picture that I put on for you is where they have in an autopsy, somebody very neatly cut away to show you the various layers of the epidermis, the dermis, the muscular layer, the connective tissue layer. So this is kind of neat, showing you the different layers. This is an actual person who at one time was living. I was watching a documentary called You Are Not Alone, and I snapped some pictures from it. Here's one of the pictures. These are just little mites that live on your skin and eat your dead cells. You just sit there and think, oh, no, 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 I don't have bacteria on my skin. I don't have any mites eating my skin. No. Just for fun, go into a browser and type in parasites in the eyelashes and look at the pictures that you get. So we have mites that live in our eyelashes. Here's their name, just in case you want to know what their official name is. It's not only in your eyelashes, but you also have it in your nose and on your cheeks. So there they are. And zoom in on them so you can see them a little better. This slide summarizes what I've been saying. You have the 4 layers if you have thin skin, and 5 layers if you have thick skin. The white layer, the stratum lucidum, is found only in thick skin, which would be the palms of your hand, the soles of your feet. The bottom layer is the basal layer, and the spinosum is the spiny layer, because once you prepare it, once you go through all the steps you need to put it on the slide and then stain it, the cells kind of wrinkle up and look like they've got spines. But this is partially because of the desmosomes. So if you remember from the last chapter, desmosomes it's like the Velcro that holds the cells together. So it's some protein and some tight junctions that are holding the keratinocytes together in the spiny layer. And then if you remember what the dendritic cells were, those are the projections from a macrophage or a white blood cell that eats invaders. The horny outer layer, the stratum corneum, can be thicker if you have calluses. So if you've ever looked at the fingertips of somebody who plays a stringed instrument, they have really thick calluses. And if you look on the middle finger, the long finger of a person, you can usually tell whether they right-handed or if they left-handed, because they're going to have a big callus sticking out on the side where the pencil or the pen rubs up against the skin. So you lay a thicker layer to resist abrasion. We talked about the stem cells down in the basal layer and how they can turn into keratinocytes. Down that deep, you've got plenty of blood and nutrients, oxygen. But as you go up and come up through, you're going to get further and further away from the blood vessels, further away from the nutrients. And so you're going to end up dying, and you're going to flatten out. And that's how you get your outer dead layer. After 30 to 40 days, then it is on the surface and it flakes off. It exfoliates as dander. Now, dandruff on your head tends to be in clumps because it's held together by oily substance. So instead of just one or two cells, you'll actually see clumps. And so you can see that dandruff. But this dander, you actually can't see, not unless you have a microscope. But you drop about 1 million cells every hour. So I always tell my students when they get up after we've had lab or they've been to lecture, they're leaving about 1 million cells behind in a little pile around where they were sitting and on the desktop. I like this picture because it shows you how rough your hair actually is and how you can see the cells that kind of overlap as they push up and out through the skin. And then you look at the skin and you see the squamous epithelial cells. You see these dead, flattened cells that are full of keratin. And you can see how easily they could just flake off. Here they are in overlapping right there. So we talked about the 4 or the 5 layers of the epidermis, and now we're going to talk about the dermis. So you have really, really thin skin in your eyelids to very, very thick dermis when you're talking about the palms of your hands and the soles of your feet. The majority of the dermis is collagen fibers. So there's plenty of blood vessels, sweat glands, oil glands, nerve endings. That's where the hair follicles are, the roots of your nails, the muscles of your face attached in the dermis to this collagen, to those fibers. So that if you pull the muscles of your face, it's going to pull the dermis and you're going to frown or smile. And then the division, the way you know you've moved out of the epidermis and into the dermis, remember, are those papilla, the nipple-shaped finger-like extensions. In the last chapter, we talked about areolar connective tissue, And now we find out exactly where it is. So just as you leave the epidermis and you're going into the papillary layer, that's where you're going to find your areolar tissue, your areolar connective tissue. So it's by the dermal papilla. There are a lot of white blood cells that are able to move around because the areolar connective tissue is kind of loose. So there's areas where white blood cells could move in if they needed to. And if you need more room, then remember the mast cells in the areolar connective tissue can release histamine, which will pull fluid into the area, cause the area to swell up, and it makes it easier to maneuver around if you've swollen the area up with fluid. And then underneath the papillary layer is the reticular layer, and you have dense, irregular connective tissue. If you think about the dense, irregular connective tissue, especially in the palms of your hands, look at all the things you can do with grasping your fingers, crossing your thumb across, picking things up, curling your palms. So you couldn't do that if you had regular, dense connective tissue. So we need the irregular, the one that has fibers going in various ways. So I need my palm to be very strong. I need the connective tissue to be very strong, but I also need it to give a little bit so that I can move my hands. I was so proud when I was pregnant with my first child because I was putting cocoa butter on my abdomen, and as I got bigger and bigger and my skin was stretching, I was young enough and elastic enough that I didn't get any stretch marks, and I was so proud. And then I went in the day of delivery and delivered, my first child was a boy. And I looked down and I looked like I had been mauled by a tiger. I had these great big red ripped looking places all over my abdomen. So just the pushing of the baby out caused stretch marks. So this connective tissue in the dermis can stretch. And then now you can see the blood vessels. So you see that's what the stretch marks are. So you've stretched it and it kind of dents in, or you've stretched it beyond where it can stretch. And then you can see the blood vessels. So it's just one of the badges of honor that you get in motherhood. These are really neat pictures. You couldn't see this under the microscope. This is more what you would see under the microscope. But if you do the electron microscope, you can see that this is the areolar connective tissue. So you got fibers here and fibers there, but you see you have spaces. So white blood cells could move in and out if they needed to in there. And I don't see any mast cells that just jump right out at me to show you those. And then the reticular layer kind of looks ropey, kind of looks like twine if you look at it under the electron microscope. So here they're showing you down in this part of the dermis, and they're showing you this part up in these papilla. So you can see that there's two different kinds of connective tissue. So this mostly are collagen. Both of these are mostly collagen. The hypodermis also has some of the areolar connective tissue, but mostly what you see is just the fat. You see the adipose tissue. They name the hypodermic needle after the place where you try to put medicine. So you try to go through the epidermis, through the dermis, and you want to inject the drug into the hypodermis. So you should be able to remember epidermis, dermis, and hypodermis because the hypodermic needle goes down in there. Uh, subcutaneous fat is thicker in women. It is thinner in infants and thinner in the elderly. Now, infants and young children have very elastic skin, so they're not going to have sagging faces and hanging down wattles on their upper arm. But unfortunately, the elderly no longer have elastic skin, so when they take the adipose tissue out from out of their hypodermis, then it's not as attractive as it is in a small child. So you have two major forms of melanin. You have one of them that is a brownish black pigment, and you have one that's a little bit more reddish yellow because it's got sulfur in it. So if you've ever seen sulfur, it's a bright yellow element. I showed this picture in the chapter where we talked about genetics, but I'm going to show it again because it bears repeating. We all of us, have the same number of melanocytes. So we have the ability to make pigment, but we are genetically programmed how much we turn on the melanocytes. So people who live near the equator usually turn on all 6 of their genes to make melanocyte, to make melanin from the melanocytes. And those who are further north, they need to get as much sunshine into their body as they can to make vitamin D, so they're not going to turn on their melanocytes. So they're going to tend to be a lot lighter. So here are your people at the equator, and here are your people around Norway and Sweden. Over there. And then the rest of us kind of fall right in this area. The majority of the people are neither really, really pale or really, really dark. So this is genetically determined. And here's a slide that kind of summarizes what I just said. Darker skin, you make more melanocytes. Excuse me, you don't have any more melanocytes. Your melanocytes make more melanin. It breaks down more slowly, but it protects you from UV radiation. People with lighter skin, a lot of times you see it clumped, so you end up with freckles. So if you took a skin sample from someone who was dark skinned and someone who was light skinned, they're going to look about the same. If you look, it's about the same. But you're going to notice that the darker skinned people are going to have this darker layer right there. So the melanin is turned on and you're making more of the brown pigment into this region than this person is. So even people who are genetically programmed to have light skin, if they go out into the sun a lot, they can tan. So they can turn on their melanocytes artificially and make more pigment that way. And people who are programmed to release a lot of the brown pigment, if they stay inside and they don't come out until the sun goes down, they're going to get lighter and lighter. So one of the things that some people are surprised to find out is people who have darker skin can get darker. So if they roll up their sleeves, sometimes it's surprising to see just like people who have a farmer's tan because they hang their arm out the window or their arm out the tractor. So their lower arm is a lot darker and their upper arm and their shoulder is a lot lighter. And the same is with people who have darker skin. They also tan. Other things that can cause your skin to have a different color is if you have a lot of blood up under your skin, and you can actually see the blood through your skin. Look how red-faced this child is, how pink his skin is. So he is so fair-skinned that you can actually see the capillaries underneath his skin, which causes his face to be that bright of a pink. One of the things that good mothers do is give their kids healthy treats instead of giving them candy bars and Coke and stuff like that. And one of the most popular things, the kids love it, the moms love it, is carrots. And so they give their kids carrots every day. And if you give your kid too many carrots, the orange pigment of the carrot will actually build up under their skin. And it won't wash off either. So it'll actually go down into the stratum corneum and down into the subcutaneous fat, and you can actually see the kind of orangey color. Now, this person is not yellow from eating carrots. This person is yellow because they have jaundice. Sometimes babies are born with jaundice. When they take the baby, they'll give you an APGAR score, and they'll tell you how well he's breathing or she's breathing. So there's various things that they look for that make up the APGAR score, but one of them is whether or not the child is jaundiced. So when you break down your blood cells, you recycle some and you excrete some in your urine. And if you're having trouble breaking it down or having trouble excreting it, then the pigment builds up under your skin. So think of when you bruise yourself, you get blood that builds up under your skin, and it's kind of purple, and then it kind of fades out to a kind of a greenish color, and then it fades out into a kind of a yellow color. Well, this is almost like you have bruising underneath all of your skin. So that's what jaundice looks like. And here's somebody who does not have their melanocytes turned on at all. This is an albino. So they have no pigment in their hair, and they have no pigment in their skin. And if you look at their eyes, they'll actually be red, because instead of seeing the color of the iris, you're actually seeing the blood vessels in the back of the eye. So I think they've colorized this picture or given her lipstick, but she would not have the bright red lips like that. And I don't know whether she's wearing contacts, but a true albino will have red eyes. Here's a picture of a child who's an albino. No pigment, and you can see the blood vessels in the back of the eyes. Here are 6 words you need to memorize. One of them is cyanosis or cyanotic, and if a person has cyanosis or if they are cyanotic, they are blue. And this is because they're not getting enough oxygen, and so the red blood cells are not red. They appear as blue. Erythema is where your skin is very red. So this could be from drinking, this could be from certain medications that you take, but often and usually it's because you have increased blood flow to your skin. So we talked about when you're exerting yourself too much and you're out, it's hot outside, you're exercising more than you probably should, and you turn beet red. So this is because the blood vessels are dilating and they're trying to dissipate the heat before you overheat and get heat stroke. A lot of times if you're scared, you'll constrict the blood vessels in your face especially. And so they talk about turning white as a ghost. This is pallor. So in this one, you're having the blood flowing through, but it doesn't have enough oxygen, so you appear to be blue. This one, you don't have blood flowing through because you shut off the blood, the capillaries to your skin. So you look white. So if you're really, really sick, you can look pasty white, or if you're really, really scared, you can look white. And then Albinism, if you're an albino, you have the white skin because you genetically are not turning on your melanocytes. You're not making the melanin that you need. Jaundice, we saw that where your skin literally turns yellow because you're having trouble breaking down your red blood cells. So they're building up and you can see it under your skin. Usually it means that there's something wrong with your liver. And then a hematoma, you and I just call it a bruise. Or if it could be a hickey, where somebody has put suction on the outside of your skin and literally sucked the red blood cells out of your capillaries, and now they're laying up under your skin. So hickeys or bruising are hematomas. Also, if you have somebody who doesn't exactly know what they're doing when they draw blood, they can tear the blood vessel, or when they pull the needle out, they don't apply pressure to the hole that they made in your blood vessel, and so the blood will leak out under the skin. The one that I hate is where they're digging around trying to get the needle into the blood vessel, and they end up just ripping it all to pieces, and you end up with this huge big puddle of blood up under your skin. So that's a hematoma, is clotted blood up under the skin for whatever reason or how it got there. Sorry about that. I just realized that the slide had slid over onto the side of the screen, so you may not have been able to see those words. Now, I'll tell you a story while you're looking at this. Sometimes you want to write some of the words down because I will be asking you these 6 questions, these 6 terms. You do need to know them. But there was a woman who came in from eastern Kentucky to have her baby at the UK hospital in Lexington. And one of the things that I find endearing and infuriating both is if you go to the doctor down in eastern Kentucky, you go with everybody. So you got your cousins with you, you got your aunts and uncles with you. So you go as a group. And so this group of people came up with this woman who was having her baby, and they were freaking out at the UK hospital because the woman was blue. And they said, oh my gosh, she's cyanotic, there's not enough oxygen for her, therefore there's not enough oxygen for the baby. You know, they were like, oh my goodness, what are we going to do? What are we going to do? And the people that were with her asked, well, what's the problem? What's the problem? And they said, oh, she's blue. And they just all laughed and said, she's always blue. That's what color she is. And that's how they came to find out about the blue people of Kentucky. So down in eastern Kentucky, there are a number of people who are genetically programmed to be blue. Interesting. One of the families are the Fugits. So here's a picture of them. Clearly, mom is normal, making normal melanin. And some of the kids have normal skin, but clearly dad is blue. And of these children, 4 of their offspring were blue. So they had 3 normal. So you have like a 50-50 chance of coming out blue or being normal. So they took the people's word that she wasn't cyanotic. She was carrying plenty of oxygen. The baby was getting plenty of oxygen. And they went ahead and delivered the baby for her. And the people went on back to eastern Kentucky. But the doctors were curious. And so they researched it, and they found that there were some Eskimos that also had the same problem. And there is a medicine that you can give them. And if they take this medicine, they pee out the blue. So it is where you have jaundice and you're breaking down your blood cells and you can't get past the yellow stage. These people would not break down their hemoglobin correctly, and so it would build up as blue under their skin. So once they took this medicine, it caused the buildup of the blue under their skin to come out in their urine. And so the mountain people thought that was really cool, that the blue people were peeing out their blue. And but so apparently it didn't affect their longevity, it didn't affect their fertility. They just were blue. Not cyanotic. Here's something I hadn't really thought about, but women have to have vitamin D in order to utilize calcium. And if you're going to be pregnant, you have to have calcium. You have to be able to put calcium in your milk, and you have to be able to make the baby itself. And the baby's going to use a lot of calcium to build it. So women can't have the darker skin if they're in an area where there's not a whole lot of sunlight. So it says it might explain why women tend to be lighter skinned than men. Hopefully none of you are going to go into a life of crime, but one of the things that people have seen on TV is a lot of people get caught because they leave fingerprints behind. And they can lift these fingerprints because there's a lot of oil on your fingerprints. If you don't believe me, just put your fingers on your phone screen or your laptop screen or your TV, and you'll see the fingerprints, or touch a window. So what some people do is they'll put crazy glue on their fingertips, and that'll fill in the fingerprints and smooth them out, but it also keeps you from releasing the oil. So I'm not suggesting you try it out. But I do watch a lot of detective shows and read a lot of detective books. Now, we look at your palm and we look at the creases in there. And if you go to somebody who does palm reading, they'll tell you, you know, how long your lifeline is and, you know, all kinds of stuff supposedly from the creases. But one of the more interesting things are the people who have an extra chromosome 21, the people with Down syndrome, have, instead of the curved lines, they tend to have a crease across the middle of their palm. You can look at your palm and then look at this crease right there, the single transverse palmar crease that is usually an indication of Down syndrome. Now, one of the more interesting cases I had a long time ago, I had a student who was a special ed student, but she was such a hard worker and she was so bright and she tried really, really, really hard. And it was interesting because we were talking about Down syndrome and we were talking about having the crease. And she showed me her hand. She says, well, I have that crease on my hand, but I don't have Down syndrome. And what the parents had done was they had had surgery on this child to fix the eyes, because the eyes are usually a giveaway that you have a Down syndrome child. And I'm not sure whether they did surgery inside the mouth or not, but you really couldn't tell by looking at her face that she was Down syndrome, but they didn't do anything about the transverse crease across her palm. Here are 4 more words that I expect you to learn what they are. Hopefully you already know most of them anyway. So a freckle is flat, and so it's just a patch of melanin. It's just a little flat area. A mole, the proper name for it is a nevy, are elevated. So they actually stick up off of the skin. And often they have hairs growing out of them. So I know I've seen people with really grody looking moles because the hairs kind of grow out really, really long out of them. So anyway, anytime you have a mole, you want to keep your eye on it, because if it changes in color, if it changes in size, or if the edges become irregular, the contour, then it may be becoming cancerous. And a cancer of a cell that makes melanin is melanoma. And most skin cancers are not fatal, but melanomas can be fatal. They can metastasize, and so you want to be very careful to watch your moles. And one of the signs, I think, of a good doctor, if you have one of those doctors you go and see every year and they do a complete physical on you, is they'll look at you. They'll look at your skin, because unless you live with somebody who will look at your back for you or look at your front or places that you can't see, you don't realize if you have a mole that is becoming cancerous. So good doctors will look and see if you have any changes in any moles that you have on your body. Here are pictures about the different skin markings that they were talking about. So here's a freckle. It's just a little brown spot right there. Looks like there's another little freckle there. And this is a mole right here. So it's fairly regular in size, and it's mostly all the same color. Now you can compare and contrast it with a melanoma right there. So you have the edges right here. You can see it's the color. Here's the normal skin, and there, that's kind of a reddish color. You can actually see it starting to move out through the skin. And you can see multiple colors. You can see the blood vessels coming in there. And then you see it's completely different than a mole. It's changed its cell composition. So you look for the border, an irregular border, color changes, and growing if it's getting bigger. A mole will just sit there. You may have it for years and years and years, and it doesn't change at all. And then this is a picture of a child with hemangiomas. So these are little, oma means tumor. So these are little tumors of blood vessels. But they're not dangerous. They're just kind of unsightly. And you can get rid of them with lasers, or in this case, you'd have to, you couldn't take it off with surgery very easily because it covers too large of an area. So there are other things that they could do to cause those blood vessels to go away. But in my case, when I was born, I had a hemangioma on my abdomen, and they just cut it out with a scalpel, put a couple of stitches in it, and in a few years the scar was gone. I was lucky it wasn't on my face. I'm going to stop here, and I'll resume the second half of Chapter 6, where we're going to talk about your hair and your nails.